Joshi, to you. So Joshi is leading Infosys. Europe is based out in Switzerland and head of practice of aerospace and defense of Infosys vertical. And he's also on the board of Infosys Consulting. You have been with the aerospace and defense sector for a very, very long time now. And we truly believe that aerospace and defense is the one sector where the advancement and adoption of digital had been there forever. It's not something new for them. However, of course, there is always some opportunity. How can you bring in that perspective for a larger manufacturing landscape and share your view that how aerospace and defense in the last few decades have already embarked the journey of digital technologies, algorithm, AI, ML. There's nothing is new for you. How they have adopted it, how now the upcoming of the reducing price of computing and the software and the hardware, all of it now is becoming commercially viable for rest of the industry to adopt, and what they have to learn from the aerospace and defense.
Sure. Thank you, Tarun. It's my pleasure to represent Infosys here. Before I actually start off, I always want to make it more contextual and more relevant. How many people are in this audience are basically from an aerospace manufacturing group? Can you just raise a hand? There's one there. The reason I asked that question is most of us, we know that aerospace is all about flying in the plane. So I think this industry, you take a step back, this is a long cycle industry. And we have this very famous saying in this industry that it's been there for 3 decades, which we've been working on. Make it digital before make it physical. So that has been a philosophy for the last several years. And what has been that basically means is, you do everything in concurrent engineering. When I'm talking about, I myself was basically a design engineer back in Airbus, and we used to have this kind of a component design, build, manufacture, maintenance team together to manage and then define the problem and start working on that. So that is a concept which has been adopted long time. So in an aerospace, and because of that, digitization of that is well adopted. Number two, historically, most of these industries have been basically either a quasi-government and basically publicly funded. So the largest compute infrastructure was very much there in that infrastructure. A lot of innovation around digital happened in this because compute infrastructure was very much there in this industry. Whereas now, fast forward 3 decades, the compute is basically commodity now, right? So I'll give an example how this industry is basically leading. If you look at in this industry, from the design till it actually retires, you're talking about a 40 to 50 years kind of life cycle, whether it's an airframe or there is an engine or anything on a component. And the people who know these aerospace industries, you'll understand that as in this entire 40 years of the life cycle, if there is an eventuality happens to that, if you're not able to trace that, where that particular material or where that process has been happened way back to 40 years, seriousness is you will actually end up losing the license to operate. So that was a mandatory which actually driven to be a big digital adoption companies. That's where the aerospace is basically very heavily digitally adopted. Now, this industry is, when it comes to the upfront, we talk about more on design space and more on manufacturing space. It's a pretty a lot of automation around that. You can look at the productivity of that much, much higher. Again, more of digital tools. But post-COVID, this industry is actually learning a lot of things from the automotive and supply chain industry. So what happened in a post-COVID is, if you just look into an aircraft, just go to an airport, you'll know that everybody wants to be flying, and then a traffic thing has gone up big. All these aircraft companies are basically airframers as well as the tier 1 companies got a major 2 challenges. One is increase rate. You're talking about probably about a 3x of the rate what we are talking about currently. So how do you make this typical batch process to the mass production process? That is something which they've been grappling with. They're learning something from an automotive industry around that. So in the MES, when everything around an optimization on the MES is something which they'll be learning. Second is, it's because you do not be able to make an enough aircraft, how do you make sure that the aircraft flies much longer, much further, and through digital technology? What is those data which has been basically there? They've been flying over 40 years, they can harness that. So back of that, with Infosys, we have actually developed this called as it's built on our AI, Gen AI platform called Topaz, which basically gives a knowledge assistant. We call it a knowledge assistant for the different profiles, the personas, right? So whether you're a mechanic on the aircraft, which is basically maintaining, or with the person who's basically doing machining in the shop, they can actually pull out the personas and then make them a digitally literal and digitally certified before they actually start getting into that. These are a lot of things which actually the other industry can straight away do it. And then it's also the good news is it's not an expensive one. Most of these are basically an open source platform, right? It's an open source. You can actually learn from that big time. And this is where I say that make it digital first and physical later. It's becoming actually affordable now. The ROI is big there. So.
Thank you, brilliant. How exciting audience, and this is something I want you to understand that when we are talking about digital and how digital is going to change, it's no more a theory, it's no more the imagination, it's no more the ideas. There is an industry which has done and dusted using digital. I mean, when you make a missiles or aeroplane, once you have thousands of aeroplanes flying at any moment and they are all connected to the ATC, what are those? Those are the classical example of IoT. Those are the classical example of algorithms, AI, ML. The decisions are taken by algorithms. And that had been happening for 40, 50 years. That's not something new. So why we in the typical process industry or discrete industry and automotive and cement and textile and pharma, why should we cast a doubt about digital? Why should we not say, it didn't happen with us, now it's happening with us. Accept it and move on, right? So that's something which we want to take away from this session. So thanks, Joshi, for that.